As scientists around the world work feverishly to meet the 2030 deadline for sending humans to Mars, one of their most critical issues, oxygen production, may be solved by two very basic organisms, bacteria and algae. NASA has reached out to private industry to devise the strategy. TechShot, a development company that has designed everything from X-ray systems for the International Space Station to deep-sea chambers for submersible vehicles, is working to develop a method that would employ bacteria and algae for the production of oxygen on Mars. The folks at TechShot believe the answer lies in the Martian soil. Why transport oxygen from Earth when it can be produced right there on the red planet? That's where the bacteria and algae come in. They will be tasked with removing nitrogen from the Martian soil and converting it to precious oxygen. This is a possible way to support a human mission to Mars, producing oxygen without having to send heavy gas canisters, TechShot's chief scientist, Eugene Bowman says. Let's send microbes and let them do the heavy lifting for us. To test their idea, TechShot has constructed the Martian environment right here on Earth. The Mars Room is a special laboratory designed to mimic the atmosphere and soil chemistry of Mars, including appropriate levels of radiation and length of daylight. And they say some of their experiments have proven successful. NASA envisions biomes, stretching across the Martian landscape, which would house vast colonies of oxygen-producing algae and bacteria. But first they'll see if it works on a small scale. They intend to send tightly sealed canisters of microorganisms aboard future rover missions that would then be implanted in the Martian soil. The canisters will then be monitored, hopefully resulting in the production of oxygen. And their concept is hardly science fiction. For these minuscule organisms have been performing this vital function on Earth for millions of years. Between 70 and 80% of the oxygen on our planet is generated by photosynthetic algae and cyanobacteria. Algae contain light-absorbing chloroplasts and produce oxygen through photosynthesis. They can be found in fresh and salt water, and on rocks, trees, and in soil. Cyanobacteria are also aquatic and photosynthetic and make up the oldest known fossils on Earth, the 3.5 billion-year-old stromatolites that dot the shallow shores of Western Australia. These organisms are part and parcel to life on our planet. And considering the fine job they do here on Earth, perhaps they can do the same for Mars.